Now let us see here. Let's take that y equal to y of x. So this is the curve. Is there the curve a of that passing through the 2 points, which making that a of x1 y1 and here b of x2 y2. So here we are taking the one curve that y equal to y of x, and the curve is passing through the two joining the 2 points a x1 y1 and b x1 y2. Okay. And let n of x, the need of x, be a function, and it is a continuous with the condition is that n of x1 is equal to n of x2 equal to 0, and then the some parameter alpha. So that alpha dot y bar of x equal to y of x into a into that n of x represented one parameter family of the functions. Okay. Now here is there. This is that. This one. This one. Okay. Where that need of x is fixed, and then we substitute y bar equal to y of x plus a into need of x, and y bar of x equal y dash of x into a into n dash of x into integral 1, and we'll get the function of the a. So that we are taking that I of a. So integral of the points x1, x2, and f of x comma y bar comma y dash comma into dx, and automatically we have to substitute the values of here, that y bar and y dash of x. So the by elementary calculus and necessary sufficient condition that integral have to the minimum or maximum extremum, then the derivation should be equal to the 0. So that I dash of alpha and equal to the derivation, that is become derivation with respect to a. So dA by dA equal to 0 when the alpha equals 0, and first derivative the initial values is become I dash of 0 equal to 0. So now differentiation equation 3 and under the integrals, and we are getting to this one, that is equation 5. So using the chain rule to differentiation function and several variables, and then we are getting this one more completely, that we are getting to that equation 6. Now since that x is independent of alpha, so dou x by dou alpha equal 0, and similarly dou y bar by dou alpha equal to net of x, and dou y by dou alpha equal to net dash of x, and substitute all the values here there in equation 5, and we are getting equation 7. And integrated the second term, and integrated on the right side by the parts. So when you are integrating by equal into parts, then the equation 6 is become in now equation 8. So the integral 8 is must be one is for the any such net of x, and the net of x is the arbitrary. So the expression in the brackets, that is the integrated must and should be equal to the 0. So this is Euler equations. Dou by dou x of dou f by dou y dash minus dou f by dou y equal to 0. Now let us come to that Lagrange multiplus method. Now we discuss the few problems with finding the extremer for the one integral subject to any required second integral on that one. This is that Lagrange formula, that dou h by dou y minus dou derivation of d by dh of dou h by dou y dash equal to 0. Now let us go into the discuss about the problems. So you just remember this one. Okay. Now here the one problem is there. Find the plane of curve. It has a fixed length. Okay, length is nothing to the perimeter, and join the points of this x1 and x2. That means this is x1. That means x coordinate x1 and x2, and enclose the maximum area between inside with the x-axis. So is here asking to find the plane equation, which is the length of L and with the joining points x1 and x2. They go to the only x-axis. This is x1 0 and this is at x2 0. So whose the length is at L. So and enclose the maximum area between itself and to the x-axis. Okay, now let's see here. Now see, this is x1 0 and this is the x2 comma 0 and one p of x1 y1 and the q of x2 y2, and this is the plane. That area is the L. Now what is the meaning of ds? Ds means what is that? The distance between the any 2 points. So we have the distance formula under root of x2 minus x1 whole square and plus y2 minus y1 whole square. And x2 minus x1 is nothing to the dx, and y2 minus y1 is nothing to the dy. So this is ds. So now if we are squaring on both sides, this is dx whole square, this is dy whole. So if we are squaring on both sides, and we are getting ds whole square equal to dx whole square plus dy whole square. Now from here, if we are taking the dx whole square is common, and we are getting 1 plus dy whole square by dx whole square into dx whole square. So from here ds equal to, we can write from here 1 plus dy by dx is nothing to that, we can write y dash. So y dash equal to dy by dx, no? So 1 plus y dash whole square into dx whole square. Next, from there, if you are writing ds whole square, no, this the value is completely ds whole square. So now the ds is become under root of 1 plus y dash whole square into dx. So totally the length is become integration of x1 to x2 under root of 1 plus y dash whole square into dx. So also the area between the curve and x-axis. So this is the curve and this is the x-axis. So thus we can write that a equal to under root of x1 to x2 by dx, and we have to maximize to the subject to that. So taking f equal to y and g equal to under root of 1 plus y dash whole square, and then we write that h equal to f plus lambda into g, and when y plus lambda into g is, we can write under root of 1 plus y dash whole square. So therefore the necessary conditions for to the extreme to the Euler equation, that we are getting dou h by dou y minus d by dx into dou h by dou y dash equal to 0. So when you are doing the differentiation with respect to y, here the dou h by dou y value is become 1 and 1 minus d by dx, and the partial derivation of h with respect to y dash, and we are getting lambda into y dash by under root of 1 plus y dash whole square equal to 0. Now if we are doing the integration with respect to x, so the one integration with respect to x is become x. So x minus and integration derivation get cancelled here. So we are getting y into lambda dash by under root of 1 plus y dash whole square equal to c1. So when we are doing the integration and we are getting to the constant, no, so that is c1. So from there we can write that y dash by under root of 1 plus y dash whole square equal to x minus c1 by lambda. So on the solving the equations for y dash and integrated again, and we are getting that x minus y1 whole square plus y minus c2 whole square equal to lambda square. So this is, we can represent it as the equation of the circuit with radius lambda and the center is C1, C2. That is the extremums of the circuit. Next, show that the for given surface area, sphere is a solid of revolution enclosing the maximum. Revolutes of enclosing the maximum. Revolutes means it's rounding. Now let us see here. Let's take OPQ be the arc of the curve. Arc means the small part of the curve. Let's here see that OPQ is the arc of the curve and it's rotated about to the x-axis. So here this is the about to the x-axis. Let the variable point P be represented by P x comma y and Q will be a comma 0. So Q is on x-axis, so on the x-axis, y coordinate should be 0 and we are taking that Q equal to a comma 0. Just we know the surface area when you are in the UG level differential integral calculus and we know that area of the surface and the area of the value. So we are getting that S equal to integration of 0 to a 2 pi y ds. So 2 pi y and ds is the length of the arc. Just now we discussed that is become under root of 1 plus y dash into dx. Now then the volume of the V of the solid of the revolution of formula, that is integration of 0 to pi y square into dx to maximum V subject to the fixed surface area, and we have to apply that Lagrange multiplier method. So let's take f equal to f of y square and g equal to this one 2xy and the root of 2 pi y and the root of 1 plus y dash whole square into dx. Now come to that Lagrange formula that h equal to f into lambda into g. So f is fy square plus lambda into g means 2 pi lambda and under root of 1 plus y dash whole square. So since h does not containing to the x, so by case C, the necessary condition h have to the extreme value, the dou hy dou y dash into y dash minus h. So that should be constant. So same apply thing here. We have to do partial derivation with respect to y dash, and we are getting this equation. So pi y square plus 2 pi y lambda y under root of 1 plus y dash whole square into c. So here when taking that constant minus c1, we are taking that c. So since the curve is passing through the O and A comma 0, and then we are getting C equal 0 and Y equal 0. So when you are putting that C equal 0, dividing through by xy, then we are getting y plus 2 lambda by under root of 1 plus y dash whole square equal 0. And when you are solving that y dash, and we are getting y dash equal to dy by dx equal to under root of 4 lambda square minus y square by y. So upon the repeating the variable and integrating onto the both side. So when we are using the variable and separable, then we are getting integration of dx, and here that integration of y by under root of 4 lambda square minus y square into dy, and with the constant. So integration of x is integration of dx is x, and integration of under root of 4y square minus y square. So that we are getting minus 4 lambda square minus y square. And at the point of O, then we are getting x equal 0 and y equal 0. And C2 equal to we are getting 2 lambda. So when you are substituting here x equal 0 and y equal 0, see what will happen. 0 equal to C2 minus 4 lambda square minus 0. So from there we are getting the C2 equal to 2 lambda. Now if you substitute that C2 equal to 2 lambda in above equation, and we are getting x equal to 2 lambda minus under root of 4 lambda square minus y square. So if you are sending to the 2y here and squaring on both sides, x minus 2 lambda whole square equal to 4 lambda square minus y square. So that is become x minus 2 lambda whole square plus y square equal to 2y whole square. That is 2 lambda whole square. There is the printing mistake more. So therefore we can say that it is a circle with the center 2 lambda comma 0 and the radius is 2 lambda. Next to that, find the geodesic on the right circular cylinder of radius A. In the cylindrical polar coordinates, then we are taking r pi z, and we are taking that x equal to r cos pi and y equal to r sin pi and z equal to z. So this is the polar form of the cylinder. On the right circular cylinder of A, then we are taking to the arc, the small part of the curve. So that is become ds whole square equal to dx whole square plus dy whole square plus dz whole square. So if we are substituting here, and finally we are getting that dr whole square plus a square d pi whole square equal to dz whole square. So when r equal to a, then the dr is become 0. So from there we are getting ds equal to under root of a square plus dz by d pi whole square into d pi. So when you are applying to the integration on both sides, so s equal to that integration of x1 to x2 under root of a square plus and dz by d pi, that we can write derivation z dash whole square into d. Now again we have to take that Euler equations. Okay. So when we have to apply to the Euler equation for the extreme value of the function for above function, then the integral of 19. So here f is a function of pi and z, and the z dash and z is a offset. So from there we can write the Euler equation dou f by dou z equal to, this is a f, no? So root x derivation is become 1 by 2 root x. Again z dash whole square derivation is become 2 into z dash. So 2 get cancelled. Here this is the f mark. So f equal to under root of a square plus z dash whole square. So dou f by dou z is become 1 by 2 root of a square plus z dash whole square. Again z dash whole square is nothing to the 2 z dash. 2 get cancelled and we are getting this one. And next z dash whole square is nothing to what is that? Dz by d pi whole square, and that is constant. And when you are doing the integration on both sides, then dz by d pi equal to constant, that is c cube, and z equal to c3, sorry, constant, then z equal to c3 pi plus, again we are getting to the constant c4. So which is the equation is the circle of helix, hence the desired geodesic on the right circular cylinder is a circular helix. Next Now the above problem is that right circular cylinder. Now here sphere. Yeah, now we are taking to the sphere polar coordinates that r theta phi, and when the system is that x equal to r sin theta cos phi and y equal to r sin theta sin phi and z equal to r cos theta. So when you are taking that an element out from the sphere of AVSA, and that we can take that ds whole square equal to dr whole square plus r into d theta whole square plus r into sin theta d phi whole square. Now that is become a square into d theta whole square plus a of sin theta whole square plus d phi whole square. Since r equal to a is a constant. So from there we are getting ds equal to a into under root of 1 plus sin square theta and d pi by d theta whole square into d theta. So when you are doing the integration on both sides, then we are getting s equal to a into that s1 to s2 under root of 1 plus sin square theta into then derivation d pi by d theta that we can write pi dash. So pi dash whole square into d theta. Now same thing we have to do that Euler equation. So when you are taking this completely f, so then by the Euler equation dou f by dou dash equal to constant. So this is dou f by dou dash. Dou f by dou dash equal to. Now we have to do derivation of this one. So from there we are getting a sin square theta by under root of 1 plus sin square theta into pi dash whole square. Same thing. Root x derivation we writing that 1 by 2 root x, no? So in the same way, and this is also we are following that. So sin square theta minus c1 whole square into dou f by dou dash equal to c1 whole square when you are taking to the constant. Now dou pi by dou theta. So that is c1 by sin square theta into sin square theta minus c1 whole square and c1 into cosec square theta into under root of 1 minus cosec square theta. This is the value. Now do the integration on the both sides. Then phi of integration of c1 into cosec square theta by under root of 1 minus c1 square into cosec theta into d theta plus c2. So from there we can write that integration of c1 cosec square theta by 1 minus c1 square of c1 minus cos theta whole square whole power of 1 by 2. That cosec secant square theta minus tan square theta equal to 1 and similarly cosec square theta minus cos square theta equal to 1. So from there we are getting this one cot theta sin inverse and under root of 1 minus c1 square plus c2. So from there or we can write that cot theta equal to a cos phi plus b sin phi, then we are getting z equal to ax plus by. Now here that using the Euler equation and we are find the extreme values which are satisfy the given conditions. So find the stationary values of the functionable I equal to integration of 0 to pi by 2 2xy plus dx by d theta whole square plus dy by d theta whole square into d theta. See there. First, let us take the conditions. F equal to 2xy plus x dash whole square plus y dash whole square. So let us take this is the f, that is 2xy plus x dash whole square plus y dash whole square. And then dou f by dou x equal to become, that is 2y, and dou f by dou x dash equal to become 2x dash, and dou f by dou y is become 2x, and dou f by dou y dash equal to 2y dash. Now hence from the Euler equations, then we can write that dou f by dou x minus d by dt of dou x by dou x dash equal to 0. So for if you substituting to the all the values here, and we are getting 2y minus d by dt of 2x dash equal to 0. So again that x dash is become again derivation, that is become d square x by dt square, and 2 get cancelled, and we are getting d square x by dt square equal to y. And similarly from the Euler equation, then we can say that dou f by dou y minus d by dt of dou f by dou y dash equal to 0, and dou f by dou y equal to 2x, and minus d by dt 2y dash equal to 0. Here dou square y by dou t square equal to x. Here there's some printing mistake is there, no? That is dou square t by dou square y by dou t square equal to x. Now to solve this simultaneous linear differential equation, and we differentiation equation for twice and use to find to solve that. Then we are getting C there. D power of 4xy dt power of 4 equal to d square y by dx square equal to x. Otherwise, this we can write that d power of 4 minus 1 of x equal to 0. When in the degree level, and we have to find the complementary function solutions. First, we have to find the auxiliary equation. There is m power of 4 minus 1 equal to 0. And this we can write m square minus 1 into m square plus 1 equal to 0. So m square minus 1 equal 0, that is become m square equal to 1, and m square equal to minus 1. Then m square equal to 1 means m equal to plus or minus 1. And here m square equal to minus 1 means then m equal to under root of minus 1, that is m equal to plus or minus I. So if the roots of plus or minus 1, and the solution is become x equal to c1 into e power of t plus c2 into e power of minus t. And when the roots are plus or minus I, and here we get c3 into cos t plus c4 into sin t. Here the independent variable t, so we are writing to the function is also in t. Okay, so that x equal to c1 into e power of t plus c2 into e power of minus t, and c3 into cos t plus c4 into sin t. Now we have to find that the solution of find the values of the constant c1, c2, c3, c4 from equation 4. So how we are getting that? So first y equal to, when you are doing the derivation, c1 e power of t derivation is become c1 e power of t, and c2 e power of t derivation is become c2 e power of minus t into minus t are getting, and cos t and sin t. Now x equals 0, t equals 0. Then we are getting c1 plus c2 plus c3 equal to 0. When you are substituting x equals 0 and t equals 0. T equals 0 means that sin t is become 0 and cos t is become 1. When y equal to 0, when t equals 0, then we are getting c1 plus c2 minus c3 equals 0. So adding these two conditions, this both, then we are getting c1 plus c2 equals 0. Again, when you're substituting that x equal minus 1, when t equal to pi by 2. So here in the equation 6, we have to substitute x equal minus 1 and t equal to pi by 2. So minus 1 equal to c1 e power of pi by 2 plus c2 e power of minus pi by 2 plus c4. Why? Because cos 90 is 0. So c3 will vanish, and sin 90 is 1. No? So we are getting only c4. And next y equal to 1, and when t equal to pi by 2, then we are getting this. So again adding these two, and we are getting this equation. Now c1 plus c2 equals 0, and next c1 e power of pi by 2 plus c2 e power of minus pi by 2, 0. From these two, we can find out that C1 equal to C2 equal to 0. So when C1 into C2, C1 and C2 equal to 0, solving the equation 7 and 8, we are getting that C1, C2 equal 0. From there, we can write that C3 equal to 0. Why? Because C there. C1, C2, 0. No, from here, C3 is also become 0. So all the values of C1, C2, C3 when we are substituting, and we are getting C4 equal to -1. Now, if you substitute that C1, C2, C3, C4 value here, and finally we are getting that x equal to -t, and from equation 6 we are getting y equal to sin t. So therefore the values are is become x equal to minus sin t and y equal to sin t. And see the next problem also is there with the conditions. So this is the function y double dash whole square minus y square plus x square. So f equal to y double dash whole square minus y square plus x square. So first dou f by dou y is become minus 2y, and dou f by dou y dash equal to 0, and dou f by dou y double dash equal to 2y double dash. So if you are substituting there all the values there, and we are getting this one. Again the d power of 4 minus 1 of y equals 0. So using the complementary functions, and we are getting c1 e power of x plus c2 e power of minus x plus c3 cos x plus c4 sin x. Same, using the given conditions, x equals 0 and y equals 0, then we are getting c1 plus c2 plus c3 equals 0. And the next derivation, the first derivation when you are doing x equals 0 and y equal to 1, and we are getting c1 minus c2 plus c4 equal to 1. And similarly, y of 5 by 4 equal to 1 by root 2, and we are getting this one. And y dash of 5 by 4 equal to 1 by root 2, and we are getting this equation. So we have the 4 conditions to need to find the y value, to find the C1, C2, C3, 4 values. So if you are solving that 4 equations, and we are getting C1 equal to C2 equal to C3 equal to 0 and C4 equal to 1. So all the values we are substituting there, and we are getting that y equal to sin x. So students, you can do this as a homework, and it is important. 0 to x by 2 f of y dash whole square minus y square plus x square into dx. Here, this is important. Here, the higher order equation is 0. Second order equation is 0. Dou f by dou y minus d by dx of dou f by dou y dash plus d square by dx square dou f by dou y double dash equal to 0. Now, observe that previous problem and this one. Here, the variables are dx by dt and y t x y, that is a dependent variable, and t is only independent variable. And when we are getting this equation, and next here there is only one independent variable and one dependent variable. Since the function is involving with the higher order, and what is higher order? And second order derivative. So therefore that Euler equation is become dou f by dou y minus d by dx of dou f by dou y dash plus d square by dx square dou f by dou double dash equal to 0. If it is only first order differential equation is that just we are writing dou f by dou y minus dx by dx into dou f by dou y dash equal to 0. But here it is uh, higher second order linear differential equation is there. So that's why we are writing this equation. So you have to observe the students. And it is important in the examination points. Here three variables are there, x, y, t. So in this term we have to get the two equations. It is only first order differential equation. So dou f by dou x minus d by dt of dou f by dou x dash equal to 0. And next similarly, dou f by dou y minus d by dt of dou f by dou y dash equal to 0. Suppose here also some dy by dz whole square into dt is there, and we are getting one more equation, that is dou f by dou z minus d by dt of dou f by dou z dash equal to 0. That is the thing.